Hi, everyone. Okay, can you hear me? Awesome. So welcome to my presentation, the vulnerabilities I found, the fun, the weird, and the technical. So my name is Roni. I'm a senior security engineer at Mano Mano. I'm 20 years old, and as you may hear, I'm also French. Mano Mano, if you don't know, is a European leader specializing in DIY, home improvement, and gardening online. We are an online marketplace. And I'm also co-leading Mano Mano's bug bounty program on HackerOne. I've been doing bug bounties on HackerOne for 3 years now, and the goal is to just, for instance, hack a target, identify the vulnerabilities, and then help the target to then fix the vulnerability so malicious actors do not find them first, right? And so today I wanted to talk to you about those bugs that are like quite fun, that are also weird, like those bug bounty stories that every bug hunter have, right? Like the cool anecdotes and your favorite bugs, right? So the first vulnerability, I was hacking with my friend Adam one night, and we were like on a chat application. And so we played a game, which is the XSS game. Basically, we wanted to send payload to one another and bypass the filters to get an XSS on the other account, right? So the goal was to get an account takeover on the other person. And so what happened is that we sent like 3 payloads, and my page turned totally blank. I thought it was like, a connection problem until Adam told me, hey, is your page blank too, Ronnie? And so that was kind of weird. For me, it wasn't a coincidence that both our pages were blank, right? And so I went looking into the console, and there was a message say, hey, there is an uncode type error. We cannot read the replace function of undefined. So that was weird, right? And so I started investigating like our traffic. And so the first payload we sent was like just a custom tag. And then we tried a B tag to have a bold text on the chat. And then we sent an A tag. So there is nothing malicious about those payloads, right? There is nothing exceptional. But yeah, that was the payload that was actually super malicious. You need to be really careful about A tags because it can break an entire application. And to understand why, you need to understand that our target was actually using a library called sanitize URL. And so sanitize HTML. And so sanitize HTML actually strips any malicious tags, any malicious attributes that may evaluate JavaScript, right? And so one of the attributes that it's tried to strip is the href when you put a JavaScript protocol. So if you write JavaScript colon and then a JavaScript function, it will evaluate JavaScript, and you get cross-site scripting on your target. And so to do that, they call a function that is actually checking the href and then just stripping the href. But the thing is, I didn't send any href. And so the function called naughty href, that's the real name of the function, was actually trying to do a replace function on the href attribute that wasn't existing. And so if you put a debugger on that moment, actually, you are like, hey, href is undefined, and so you cannot execute the replace function of undefined. And then since the page was built on React, it went totally blank, like it just crashed. And so at that moment, we got an application denial service on our target. It took us 5 seconds to find it. And actually, it was quite impactful because our target was a real famous chat system where there could be hundreds of people streaming at the same time. And so you can just dose everyone at once. So it was quite fun. OK, let's go into a more weirder vulnerability, a bit more technical. So another night, we were still hacking with Adam, and we were on the same target. And we wanted to check like authentication and password reset functionalities to find vulnerabilities, right? So we just wanted to concentrate on those kind of endpoints. And then he sent me his password reset token, and he told me, hey, it is on another domain, it's weird, but for me, there was like a vulnerability. Instantly when I saw, I was like, oh, that's something super vulnerable. And to understand why, the token was looking like this, right? And if you have been doing bug bounties, you surely recognize that this token is a UID. And to understand why I thought it was a vulnerability, a few weeks before finding that, I was going on the internet to check for password reset token hacking, and because I wanted to become a lead hacker that know how to guess password reset tokens. And actually, there is a research of Versprite team where they did a research on how secure UIDs. And so they explain how UIDs are actually constructed. So first, you have a version. So version on a normal UID is on the third chunk, and it's the first character of the third chunk. And so you get like the version. If it's 1, then you got a UID v1. If it's 4, you get a UID v4. Then you get the clock and the MAC address of the machine generating the UID. So the MAC address is always the same for a single machine, so it's just the MAC address of the machine. And then you get a clock, which is actually a default value when first starting the operating system. So it's always the same for a single machine. And then we got the high, mid, low. And to understand what is the high, mid, low, you can like put them together, and you get an hexadecimal value. And then that hexadecimal value, when you put it in decimal, you get a timestamp. And so for people that know what a timestamp is, that doesn't look like a timestamp, right? And so actually, it is a timestamp, but in the Julian calendar. So why using the Julian calendar? I don't know. That's super weird. Why not using epoch timestamp? But then with some really complex and deep mathematics, you can just subtract the difference between the Julian calendar and the Gregorian calendar, and then you divide by 1,000 to get the amount of seconds that has passed since January 1st, 1970. And so from here, you get a date. OK, that's awesome. But what is the vulnerability with that? So at that moment when you understand that UID v1s are generated using timestamps, it means that, for instance, you can send an attacker to the attacker account a UID, a password reset token, right? And then you send another one to your victim. So if you know the victim email address, you can just send a password reset token. And so now you generated 2 tokens. You add some tomatoes because this is not a really great sandwich without it. And then you send another UID to the attacker. So you got 3 UIDs. One to your attacker, one to your victim, and another one to your attacker. And what happened is the victim password reset token is in between of the 2 that you generated for the attacker. This means that now you get like a time range of the different possibilities of your victim reset token. And so in our case, when we divided, when we subtracted the 2 times, we get 100,000 possibilities of UIDs between the attacker and the victim. And so what happened is that we had 6 different machines that could have generated this UID. And remember, the clock and the MAC address is always the same for a single machine. This means that now we can just multiply 100,000 with 6, and you get 600,000 different possibilities. And since our target generated password reset tokens that were lasting 3 days, we got 600,000 possibilities to brute force over 3 days. And of course, they didn't have any rate limiting. So it was kind of easy to get a zero-click account takeover from that. And actually, we got rewarded $5,000 for that vulnerability. So it's actually great for a zero-click account takeover, especially since it was an out-of-scope asset. And actually, we talked about that vulnerability on a French TV show called Underscore. And there was one comment that just said, you should rename this technique from a French sandwich, really famous. And so, ladies and gentlemen, today we're renaming this technique the jambon beurre attack. Okay, let's go to the third vulnerability. And this one is one of my favorite that I found on the last 3 years. So that wasn't bug bounties. That wasn't my job at Mano Mano, where I found a zero-click remote code execution. So to the story, I sent a Slack message to the whole company, to all the developers, asking, hey, can you help me find a vulnerability? It's not important what I was seeking, but it was something in JavaScript files, right? And so one of the developers told me, hey, you should look at that domain. I don't know if there is the vulnerability that you are looking for, but it seems strange to me. And so what I found on that domain, there was a GitLab token in the JavaScript. So that was weird, right? Why there is a GitLab token in the front end? And so I went looking from where it was injected, and actually we had a config.json file that was injecting this GitLab token. And so I tried to use the GitLab token as a private token, and it didn't work. I got 401. So actually, what was the utility to get this token in the front end, right, if it's not working? And so I dig deeper into JavaScript to understand how this token was used. And actually, I found this request in the JavaScript. And so you see that the URL was just a post request in a multiple form data with an API that was triggering pipelines. And so actually, I went into the documentation of GitLab, and I saw that there was actually API's token that was only useful for pipelines. So when you are creating a pipeline, you can create a API token just for this pipeline. And so you get one API token for pipeline that you want to trigger, right? It's not one token for all pipelines, it's just one token per pipeline. So why there was a pipeline token in the front end? So it's not answering my question, right? And I went looking further why there was this type of vulnerability. And I saw that actually we had a feature to help developers set up application in our GitLabs. And so the goal was to just put the name of your project, and it was setuping everything you needed. So every guidelines that we wanted to enforce, and every libraries, everything it was installing by itself. So actually super useful for developers to get that, because they do not need to bother with everything. And so when I tested to use this token, actually I managed to create a pipeline. So now I'm running pipelines on our internal GitLab. Okay, that's awesome, but what can I do with that? So my goal at that moment was to find a royale with cheese. For me, the royale with cheese is a remote code execution. That's how we name it at Mano Mano. And so to understand why I wanted a rail with cheese, because I could have just stopped here and just say, OK, we can run pipelines, just fix the vulnerability, is that one of my colleagues challenged me to find a remote code execution. And actually, my colleagues love to tease me, because at the time, I was there at Mano Mano for 1 year, and I didn't find any zero-click remote code execution. And so they were telling me, OK, you didn't find any zero-click RCE, so now you need to find one. So the challenge was accepted, of course, but Andres, one of my colleagues, told me, you need to do that by tomorrow. So it was kind of hard, and so I decided to dig even deeper. And so I went looking in the source code, and I saw that in the post request, we had like a GitLab token that was actually a user input. So what was happening is that you provide your own personal GitLab token, and then it is used to clone the project, and then it set up the project for you, right? And so it's directly into your GitLab account. But the thing is, this is like the URL. You get the username, the password, and then you get a domain. And now the question, what if I'm able to inject that payload as a API token? What's happening here is that the username is still GitLab CI token, the password becomes hello, and then after the @ this is the new domain. And then the previous domain is becoming the path. And so at that moment, I got like some kind of server-side request forgery where I could force the backend, the pipeline, to actually clone a project from my server. But there was another problem with that, is that actually there was a dangling path, the dangling domain inside the path. And so I didn't manage to set up any GitLab project or any GitHub project with the dangling. It just didn't work in the way that it was doing the clone. And so I needed to create my own Git server. And so what I did is that the root of my computer, the home of my computer, I just created a directory with my dangling domain. Then inside that domain, I was initiating a project and copying some malicious code, right? And I was committing that malicious code, and then using git update server info to make it like as a real server. And then I was copying every files needed for the Git clone in the root of the project. And then at the home of my computer, I just put a web server listening for any incoming requests. And at that moment, I managed to clone repositories from my own computer inside the GitLab pipeline. So that was cool. Now I got arbitrary file right, but actually arbitrary file right just in one domain, and I couldn't do any path traversal. So again, I got another problem, how I turned that into a remote code execution. But remember, as I said, we were creating templates repositories, right? And so when you hear the word template, there is Jinja behind it. And so we actually use internal repositories with some templating, and then the pipeline was running Jinja to create a new repository. So knowing that it was Jinja, all you need to do then is to put that payload, which actually is importing the OS library and then executing the system function to get OS calls. So at that moment, I just did a curl on my own domain, and it worked. It actually cloned my repositories, and then I get a curl back to my server. And at that moment, I managed to get a remote code execution in 0-click at mano mano. I managed to get my royal with cheese. So just to sum up, we found a token in the JavaScript public. Then we triggered the pipeline that cloned my own repositories, which means that we got remote code execution on the internal network of mano mano. So that was super fun. That's the end of the presentation about like 3 bugs, 3 small examples of vulnerabilities that I found in the past 3 years. Those bugs that I really like. They are not the most technical ones, but they are pretty cool for me. I wanted to take the occasion to thank everyone that really helped me so far. There is Adam, which we did a lot of Bounty, Brice, too, which we collab, all my colleagues at Mano Mano, and thanks to you for attending this presentation. You are awesome. Do not hesitate if you have any question. Great. Bye, everyone.